Hello, we have been working on solving quadratics, and so today we're going to review all of the different ways to solve quadratics, and then we're also going to practice just using those methods. So the four different ways are factoring, graphing, the quadratic formula, and square roots. And each method has some good parts about it, and each method also has some drawbacks. So part of the goal today is to figure out when should we use which method. So here you'll see kind of a quick recap on how to solve quadratics just using the different methods. So for the first one, by factoring, in order to factor, you set instructions. Then you're going to want to factor the quadratic, so it looks like that. You're going to set each factor equal to 0, and then you're going to solve the equation, and you're going to get answers like x equals some number, or whatever variable that you're solving for. You'll get that variable equals some number. Now this method is really nice. It's probably one of the quickest methods, but it's not always going to be appropriate. Sometimes it just isn't going to work. So when it doesn't work, it is not going to be appropriate to use this method. So meaning when it doesn't work means that it's not factorable. So you try your number pairs and you can't figure out anything that works. So for instance, x squared plus 26x plus 1 equals 0. There's no number pairs that are going to work. So the factoring method, while it is one of the fastest methods, it just does not work when something doesn't factor. So then another method we have is graphing. So graphing, you want to actually take and you want to find the vertex. So if it's in standard form, which is ax squared plus bx plus c. You find your vertex by doing negative b over 2a, and then you plug it in. In vertex form, which is x minus a parentheses x minus h squared plus k, your vertex is h comma k. After that, you're going to take a, and you're going to multiply that by the 1, 3, 5 pattern and graph it. And you're going to locate the x-intercept. So the x-intercepts are going to actually be your solution. So wherever those x-intercepts are, you're going to write x equals those numbers. But once again, this method does not always work. It's not always appropriate to use. There are two different cases when the x-intercepts aren't nice, meaning when they're a decimal like 0.62943 that keeps on going on. The other method, or then other time that this method is not appropriate, when there are no x-intercepts. So when your graph looks like this, it doesn't cross the x-axis, but there still are two solutions to that quadratic. It's just that they're imaginary. So then what we did is we said, hey, well, in those cases, we can also solve using the quadratic formula. So the steps for the quadratic formula are get it equal to 0. You're going to plug in all of your different parts into the quadratic formula, and you're going to simplify. So this method is, if you want a go-to method, it would be using the quadratic formula because it's going to work no matter what. It does become a little bit more complex to simplify, but then the other thing is, like the other methods, honestly, are going to be shorter most of the time as long as they work. So when is this method not appropriate? It's when the other methods work or are shorter slash fast. That would make them a little bit more easy to use than the quadratic formula. However, the quadratic formula will always work. Then the last one we learned was solving by taking square roots. So you want to get the x squared term alone. So it's going to say like x squared equals something. You're going to square root both sides. So it's going to be like plus or minus square root of whatever that was. And you're going to simplify. So this method is very fast, but it does not always work. It only works when you have an x squared and a constant. So when is this method not appropriate? When there is an x term. So if you had an x squared plus x equals 0, you could not use square roots. So looking at those are the four different methods. And so what we're going to do is we are going to practice using those methods. So for this first one, we're going to focus on factoring, graphing, and the quadratic formula because we cannot use the square roots for this one. So we want to find the zeros for this quadratic equation. The zeros are another way of saying the solutions when y equals 0. So in order to factor it, what we're going to do is we're going to replace y with 0. And the first step of factoring is to get it equal to 0, which it is. Now we're going to do our number pairs. We are looking for what multiplies, get 27, but yet adds to get negative 12. And so those numbers are going to be negative 9 and negative 3. Because there's a 1 out in front, what we can do is we can just write our number pairs as our factors. So x minus 9 and x minus 3. So we have now factored. Now what we're going to do is we are going to set each factor equal to 0. And after we set each number pair or factor equal to 0, we're going to solve those equations. And we're going to get x equals 9 and x equals 3. Okay, so I'm going to zoom out just a little bit. So our two solutions here are x equals 9 and x equals 3. So that is how you solve by factoring. Now we're going to move on to graphing. So again, we had y equals x squared minus 12x plus 27. As a reminder, we are looking for the x-intercept. So this is in standard form. We are going to do negative b over 2a. So b here was negative 12, so it's going to become a positive 12 over 2 times 1. So that becomes 12 divided by 2, which is 6. What that tells us is the x value of our vertex is 6, and we need to find our y value by plugging 6 in. So we're going to do 6 squared minus 12 times 6 plus 27. So we have 36 minus 72 plus 27. And when we simplify all of that, we get negative 9. So our vertex is at 6 comma negative 9. So we're going to go ahead and make that point on our graph for our vertex. We're going to do 1, 3, and 5 times our a value, which in this case is 1. So our graphing pattern is over 1, up 1, then over 1, up 3, then over 1, up 5, and then 7 since we have the space here. So this graph is our parabola. And so for graphing, once again, we're looking for our x-intercepts. So our graph crosses the x-intercepts, or the x-axis, at two nice spots. Those are x equals 3 and x equals 9. So those are the zeros for that quadratic function. And notice, they are the exact same as the part in A because it is the same problem. It's just a different way of solving it. So now we are going to use that same equation and we are going to do the quadratic formula. So again, we're going to replace y with 0. So it's 0 equals x squared minus 12x plus 27. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So looking at our equation here, a is 1, b is negative 12, and c is 27. We're going to take and plug in a, b, and c. So we're going to do negative b, which turns into positive 12, plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to go ahead and simplify this. This negative 12 squared becomes positive, or 144. And then 4 times 27 is 108. And then we are going to simplify that further. 144 minus 108 is 36. And I'm out of space, so please pardon me. I'm going to go over here. You do 12 plus or minus 6 over 2. Notice I'm not dividing by 2 until the very end because now I don't have a radical anymore, so I can actually divide both of these by 2. This can become 6 plus and minus 3. So now what I can do is 6 plus 3, which is 9. So x equals 9. And 6 minus 3 is 3. So x equals 3. And so you'll notice if I zoom out here and look at all of these different methods, I got the exact same thing with all of my different methods. It's just different. You got to choose the one that works best for you. But again, factoring won't always work. So if factoring doesn't work, go to the quadratic formula. Or if graphing doesn't work, then go to the quadratic formula. So hopefully this helps. And go ahead and try those practice problems that are after this. And I hope you have a good day. Thanks.